Has this ever happened to you?
You're trying to fill your measuring cup, but you just make a big spill.
Not again.
What a mess. Or how about this?
Let's see. Third cup of flour.
You can't even find the measuring cup to begin with.
Not again.
Measurement sure can be a hassle. Thankfully, all these problems are a thing of the past with the new Smart Hopper. It serves as a dedicated storage unit for any dry good you want, and it can make accurate measurements. You don't have to find the ingredient or the measuring cup ever again. Also, it contains all the mess to a single confined space, reducing your cleanup time. Let's listen to one of our happy customers.
With the invention of the Smart Hopper, I get exactly how much I want, when I want, with no mess at all. I just set the dial to 30 grams, push a button, and it dispenses exactly 30 grams for me.
Amazing! Now, let's meet who created such a wonderful device.
Hello, my name is Grant Felton, and I'm a civil engineering major.
I'm Ritch, and I'm a mechanical engineering major.
I'm Christian Bock. I'm a mechanical engineering major. And this product is our Honors 122 Spring Quarter Louisiana Tech 2024 Design Expo project, the Smart Hopper.
With this, we sought to make the kitchen cleaner, easier, and more efficient for the average user.
Now, let's take a closer look at how our product functions.
Great idea, Grant. Let's start with some of the sensors we used. For general function, our project includes an Arduino Uno, 2 breadboards, 2 10-kilogram load cells, a load cell amplifier, a motor driver, and a micro DC motor. For the user interface, we used 2 momentary switches, an LCD screen, and a potentiometer with a dial. Now, Grant will show how all of these pieces work together.
The way it works is on the LCD screen here, it shows your current mass and how much you want to dispense, which the amount to dispense can be altered with this dial right here. Say I want to do 20 grams. So then I would go ahead and click this blue button right here, and then the DC motor at the top spins a corkscrew down at the bottom, dispensing exactly how much flour that I had it set to dispense, which in this case was 20 grams. I also have this other button over here that when held down will just dump until you have however much you want. It'll just go non-stop. And as a fail-safe, in case I put the dispense up to too much and more than my current mass, if I go to click it, it'll just say not enough ingredient instead of breaking the machine.
Excellent demonstration. Now, let's move on to some of the hardware. As we've seen before, whenever we push this button, flour comes out in a controlled manner. How does our hopper accomplish this? If we look inside, we'll see a corkscrew and some agitators. Flour is trapped along the threading of the corkscrew, and it is funneled toward the main output hole and into the user's bowl. As the screw turns, these tiny bits of flour are led down the hole, which allows us to dispense the flour in a controlled and accurate manner. All weight measurement done by this system is completed by the 2 load cells mounting the main hopper body, pictured here. Now, let's move on to discussing the code with Aaron.
Alright, so here we have the main code of the function. Right here is where it starts. It does simple stuff like finding the weight and getting the reading from the potentiometer. It also has, if we need to, for the button pushes, it can dump all the ingredients we have, and if the button is held down, it will even zero the scale and go back to the start. If you have a valid reading for the amount that you want to dispense, it'll go through the dispense function, which, if we come to here, it does some math to find out how much weight we need to dispense and what the weight will be once we reach that goal. It will then set the motor speed to max and will come down here to where it starts dispensing it and slowly subtracting until it reaches the dispense we want. After that, it then sets the motor control down to false, which means it won't start anymore. These functions are controlled by these other user-defined functions, which help make it easier and simple to read.
For the Smart Hopper, we use the electrical engineering discipline to wire the sensors together so that they can all work effectively.
We used the mechanical engineering discipline to design the frame, holding brackets, hopper itself, and moving parts of our prototype.
We use the cyber engineering discipline to help write the program that helps move all this so the thing actually works.
Well, what are you waiting for? For the low, low price of $200, you can get a kitchen experience that is truly priceless. This has been the Smart Hopper team, and thank you for listening.